So this video is on our notes for block day number 1, Tuesday, May 18th on math modeling 4.8 notes. And these are on something called sinusoidal math modeling. That just basically means we're going to be dealing with sine and cosine graphs. So you're either going to be giving me y equal a times sine b of x minus h plus k, or y equal a times cosine b of x minus h plus k. Those are the equations you're going to use. If you know your 0 to 0, use your sine. If you know high to high or low to low, use your cosine. That's kind of my rule of thumb. You can do any of them in either form, but sometimes maybe one is going to be easier than the other. So what we're going to be doing in this problem is we have a Ferris wheel. Pictured at the right. Darlene is sitting in seat D right here, this point labeled D. Okay, we aren't quite sure where she is on the Ferris wheel in terms of height. Okay, we know that the whole entire Ferris wheel reaches the highest point of 45. Okay, we know that from the ground to the center of the Ferris wheel, that this from here to here is going to be the 25, which means whatever is left over from here to here is going to be our radius. So if I was to take 45 minus 25, I get 20. That means our radius for this circle is going to be 20. And that means that we're going to be having basically 5 below. Okay, so hold on, let me. Okay, so again, since that is 25 to there, this is going to be 5 from here to here because of the 25 from here to here. Okay. So when we're looking at this problem, okay, some more information that they gave us is that the ride starts at time t equals 0. And it takes 10 seconds for Darlene to reach the top of the wheel, where she'll be 45 feet above the ground. We also know that the wheel turns at a uniform speed of 2 revolutions per minute. So one of the questions they're asking us is, what is the radius of the wheel? The radius of the wheel is 20 feet, as I showed earlier, taking 45 feet total, the whole height minus to the center, which is 25, and that gives me 20 left over. How is the value related to the sinusoidal graph that represents the scenario? It is our amplitude. This is our amplitude. Okay, our amplitude is going to be 20 feet. Okay, our A. Now it might be a negative or a positive 20 depending on how we start our graph or our equation. Then it says, how long does it take to complete 1 revolution? Okay, so 1 revolution, we know 2 revolutions is 1 minute. So 2 revs is 1 minute or 60 seconds. So if I reduce that, I can divide both top and bottom by 2. I get 1 revolution in 30 seconds. Okay, so 30 seconds equals 1 revolution. How is this value related to the sinusoidal graph that represents the scenario? This 30 seconds is going to be our period. Okay, that's going to be our period. So then it says, what is the minimum height above ground that Darlene reaches? So the minimum height, again, is this 5 right here. That's going to be the minimum because it was 25 to the tip to the center from the ground, and it was 20 for the radius. So that's going to leave us 5 left over. Okay, so the minimum is going to be 5 feet. Sketch a graph to model this scenario. So we're going to do that. So for this, I am going to do kind of an L-shaped graph for this one. My x-axis is going to be time in seconds. My y-axis is going to be feet above ground. And if we're looking at the picture here, I know that the highest this Ferris wheel is going to go is 45. I know that the lowest anyone on this Ferris wheel is going to be at is 5. I also know that the center of this Ferris wheel is going to be at 25. Okay, so the highest we're going to have is going to be 45. The lowest is going to be 5. And again, it was centered, the radius or the center of that circle is at 25 feet above ground. So that's going to be 25. Now, sometimes you might not be able to see it visually. If you take your high and your low and average them, so add them up and divide by 2, which would be 50 over 2, which is 25. You're going to get that same value I got right there. So we saw it in the picture, but sometimes you can't see it that way. So you're going to take your high plus your low divided by 2. We call that averaging. Okay. You're going to average your high and your low, and that would give you your center. Okay. So now I know my vertical shift or my zeros are going to be at a height of 25. And my highs and lows are again going to be at 45 or 5. Now I need those 3 values. I need you to give me those 3 numbers, your high, your low, and your middle, okay? Or where your zeros would be. Now I need to look at the x-axis. One bit of information I know is that 10 seconds from when the ride started, Darlene is at the top of the wheel. So that 10 seconds is when she's at the top of the wheel. Okay, top of the wheel is going to be here. So I'm going to put 10 seconds and she's going to be at a high. Now, at this point, I'm going to think cosine because I'm starting at a high. I'm not starting at a middle or my 0. That would be a sine. I'm starting at a high. High or low cosine. And I always plot 5 points. So I'm going to have 10, and then I'm going to go 1. So that's 1, 2, 3, 4, 5. So these are going to be my 5. Now I need to figure out what value this one is, but I'll figure that out in a second, but I can actually just graph this as is. So I start at a high, 1 revolution around, which would be 1 period. I'm going to end at a high. Halfway in between, we're going to be at a low. And halfway in between, we're going to be at our 0, which in this case is our 25. Okay. And there is my cosine graph. And again, I'm going to do this as a cosine. And let me just darken in. Okay, so that. Now, I know that my period is 30 seconds. Now, what you don't want to do is come here and put 30 here. No. Okay, my period is 30 seconds long. It doesn't mean it has to end at 30. It's going to be 30 beyond where we started. So I'm going to add 30. And so I end up at 45. Sorry, at 40. I apologize. Now, I don't necessarily need all the values in between, but every so often it might answer some of the questions you see in a word problem. So to find this value, basically do like we did over here. We're going to average the start and end. So I'm going to take 10 plus 40 divided by 2, and that's going to give me 25. And that 25, let me just circle this, that 25 is going to go right here. And then I'm going to take the 10 and the 25, and I can average that, which is 35. And I get a divided by 2 is a 17.5. So then this value here is going to be 17.5. And I can do the same on the other side. I can take 25 plus 40 divided by 2. That's going to be 65 divided by 2. And 65 divided by 2 is 32.5. So 32.5, that's going to go right here. Again, I need your start and your stop. I don't necessarily need the ones in between, but sometimes it does answer questions. So I want to make sure everyone understands how to find those values if you needed to. So that's your graph. So now the next thing, we're going to want to write this as a sine or a cosine. Since I start at a high and I end at a high, I'm going to do cosine. Okay. So I'm going to have y equal, and I'm going to do cosine. I know my amplitude, we talked about that earlier. It's the distance from here to here, and that is 20. So I'm going to have 20, and it's going to be a positive 20 because I'm starting at my high. And I said I'm going to do cosine. Now to figure out my b, I need to remember my period, and my period was the 30 that I added on here. Remember, I added on that 30. So to figure out that, I go 2 pi over b equals 30. So I get 2 pi over 30 equals b, which means when I reduce that, I get pi over 15. That's my b. Pi over 15. And just a quick note, if your x-axis is scaled not by pi's, you have a pi in your b. That's always going to be what happens, because when I take 2 pi divided by something and I don't have any pi's anymore, I had to have a pi on the bottom to cancel. Okay, and then I'm going to start at this point here, which is 10 comma 45. So this is going to be an x minus 10, and then my vertical shift is 25, so plus 25. That's my equation. Okay, so now what is Darlene's headed at the beginning of the ride? I didn't see where she was at the beginning because I did not have that in my graph. So I'm going to put 0 in for x. And so I'm going to have y equal 20 cosine pi over 15 times, in place of my x, I'm going to put 0. Okay, I'm going to put 0 in place of my x, minus 10 plus 25. And I'm going to put it in my calculator. And when I put this in my calculator, let me get that here for us. You want to make sure that you're putting it in your calculators in radians. Here, let me move this up so I can make this a little bigger. Your calculators in radians. See if I can make it any bigger now. Okay, let me get this bigger at least. Okay. So you want it in radians. And then I'm going to go 20 cosine. And I'm going to do alpha and y equal to get fraction option. And I'm going to put pi, which is second and your raised to the power, the caret button, over 15, parentheses 0 minus 10, close, close, and then plus 25, and I got 15. So this is going to be 15, 15 feet, 15 feet. Now it says, when is Darling closest to the ground? Well, the ground was when my y was 5. So that's what we're going to put into this equation, okay? So I'm going to go not y equal, 5 equal 20 cosine pi over 15 times x minus 10 plus 25. And we can solve this algebraically, but I think what's the easiest thing to do is actually use your graphing calculator or Desmos. I'm going to show how to do it on the graphing calculator, and I'll show you how to do it on Desmos. So we're going to enter in the equation into the y equal, okay, this equation here. That is my cosine graph. And I'm going to also enter in y equal 5. Okay, I'm going to enter in both of these and see where they cross. Okay, so I'll do that first, like I said, on my graphing calculator. Then I'll show on Desmos. It's actually easier on Desmos, but next year you're going to need to know how to do it also on a graphing calculator, because we won't be able to necessarily always do things on Desmos on tests. Okay. Okay. So I go to y equal, and I'm going to go 20 cosine of pi. Let me enter this in, pi over 15. Oops, what did I do? I deleted, sorry. 20 cosine of pi over 15 times x minus 10, close, close, plus 25. And then I'm also going to enter in y equal 5. Now, if I hit graph right now, you're not going to see it where I want it. So if I hit graph, okay, it's not necessarily scaled where I want it to be. So what I would recommend doing for this is, here, I'm going to turn this off for a second. Turn it back on. Go to window, and in window, I'm going to adjust my x-axis to be how we had it in our picture. So in our picture, we went up to 40. So let's say I go from 0 to 40 on my x-axis by ones, or here, maybe by fives. And then my y-axis, 0, and we went up to 45. Maybe I want to go a little beyond that, and maybe even over here with this 40. If I want to see where it ends, maybe I'll go to 45, give myself a little space. For this one, I'm going to go from 0 to, let's say, 50. So I give myself, again, a little space by ones, and then I can hit graph. And here is our graph. And so on this, we actually can see in our picture that it hits that at 5, that 5 at 25 seconds. Right here, we can see that, okay? That's what's happening down at the bottom of my graph right here, okay? But sometimes it might be something that you need to find, and you can't find it as nicely by looking at your graph. So on these calculators, they're on the trace button, there's the word calculate. So I'm going to do second and calculate. And number 5 is an intersection. Okay, so I'm going to hit number 5. And what it's going to ask you to do is it's going to ask you to go to where they cross. So looks like they cross here. So this is going to say first curve, and I hit go to where I think it is, and I hit enter. And then sometimes it'll jump to the second curve depending on how close I am. And then it says, hey, how is this? So what it's doing is it's really just staying at the X, but jumping up or down to where the Y is for that other graph. And so I hit enter. And then it gives a guess, hit enter. And then it's going to give me the point of intersection. Now this is giving me 24.9999999. That's going to be 25. Okay. And that's what I see from my graph on that I physically drew. But sometimes there might be something before the graph. And so you want to also make sure, but in my case, you can see here is my Y axis. That's at 0 seconds. It did not happen until first time 25. Okay. Now, if I am doing it using Desmos, okay, let me get Desmos up. So I'm going to enter in my equation, y equal, and you can either type in cosine or you can come here to the keyboard and go to functions, and here's all of our trig. So I can just do cosine, and it was pi divided by 15. Get out of my denominator, parenthesis, x minus 10, close, and then plus 25. And then I can also type in y equal 5. And hopefully I can see. Now, what I would recommend doing is going to the wrench and changing this x-axis to what I had on the other one, which is, let's say 0 to, let's say, I'll go to 40 here, okay? And then from on my y, from 0 to 45 was as high as I went. And oh, I forgot my 20. Forgot my 20. There you go. There's my 20. I'm like, wait, this is not the right graph. And then again, you can see, okay, here, this one, it did not hit the height of 5 until, and then click right here and you can see 25. That's a little easier math, but you want to know how to do it on the graphing calculator also. Okay. So again, on this, my answer to this was 25 seconds. That was our answer. Okay, so now we have another situation. This one is a water wheel. So it's going down into the water. It says that 4 revolutions per minute. The height h of a point P from the surface of the water as function of time t seconds can be modeled by an equation of the form. So here I have both of the forms. Now I have h of t here. So I am going to put a t here in place instead of that x, and same over here. Okay, so h of t for time. Okay, and that's our equation. Okay, so if we're looking at this picture, they're going to want amplitude, they're going to want period, they're going to want max height above and how far below the surface. Okay, so amplitude. Amplitude is going to be your radius. So this radius of 10, so radius equals 10. And so our amplitude is 10. I'll just put amp. Amplitude is 10. Now they also have that this is, if this is water here, so this is water, that this is 7 above. Okay, that's where the center is at 7, which means if I do that radius of 10, that's going to put me up at 17. Okay, let me do that 19 so you don't think that that's my So 17, because I'm going 10 higher than my center, which is at 7. And then my radius is 10. So if I'm going down 10, that means that this down here is going to be a -3. Okay, that's where I'm going to go below. Okay, so it says what is the amplitude of the height function? So again, amplitude is going to be our radius equals 10, which equals our amplitude. That is our amplitude. The period. They told us it's 4 revolutions per minute. So I've got 4 revs in 1 minute, which is 60 seconds. So if I simplify that and divide top of bottom by 4, I get 1 revolution in 15 seconds. So my period is going to equal 15 seconds. The maximum height, that is that 17. So again, I'm going to take my center, which was 7. I'm going to add my radius, and that is going to give me my max height of 17 feet. And then going the other direction, going down, I take 7, which is my center. And this time we are going 10 below this, which is going to give me a -3 feet. And that's my lowest point, 3 feet below. Okay, so now we're going to write and draw, well, he wants to write a graph. You may use sine, write an equation, sorry, sine or cosine. We know that suppose point P emerges from the water just as you start a stopwatch, and P reaches its maximum height above the surface after 5.6 seconds. Write a sinusoidal equation for the height function. You may use either sine or cosine. Okay, so I'm going to draw a graph first, and then we're going to write our equation. Now I'm going to go below the water surface. Okay, so this right here is our water. Okay, and this X is going to be time in seconds, and then this is feet above water. And so our maximum is 17. Our minimum is -3. And my center was at 7. Draw this more realistic. So, and again, if I was to average these, add these up, I get 14 divided by 2, I get 7. You can always add your high and your low, divide by 2, and that will average and give you your center, or what I call the vertical shift. So I know we have a vertical shift here. I know we have a high of 17 and a low of -3. They told us in this problem that we have that the max height is 5.6 seconds after they started timing. So I'm going to have 5.6, and I'm going to do 1, 2, 3, 4, 5 values. Okay. And those 5 values, I will figure out this last one here because I need the start and I need the end. I know that the period is equal to 15 seconds So what that means is I'm going to go from here to here. I'm going to add 15 seconds on. And that's going to give me this value right here. And so this value right here is going to be 5.6 plus 15, which is 20.6. Now, if you want to find these values, you can average them. 5.6 plus 20.6 divided by 2 to find this one, and then average these two to find this one, and these two to find this one. But I don't need that. I need the start and I need the end. Now, we know that this is going to be at a height, the max height. So I'm going to go at 5.6 to the high. And one whole period, if I'm starting at a high, I'm going to end at a high. And this is going to be a cosine. And then halfway in between is going to be my low. And halfway is going to be my 0 and my 0. And then I have my, I'm going to think of this as a cosine graph. And then we're going to write our equation. And again, I'm going to write it as a cosine because I'm going high to high. And my amplitude is the distance from here to here, which was our radius, which was 10. It's going to be a positive 10. So 10 cosine. My period is 15, and I know 2 pi over b equals 15. So 2 pi over 15 equals b. So that's going to be my b. 2 pi over 15. And again, I'm starting at this 5.6. That's the first value I'm going to be graphing. So I'm going to go x minus 5.6. And then my k is 7, because that's my vertical shift plus 7. And so that's my equation. Okay. Now I'm going to use this equation to help us figure out the following. When is the first time that the wheel is at a height of 12 feet? So again, I'm basically going to enter in y equal 10 cosine 2 pi over 15 times x minus 5.6 plus 7 into my calculator, and y equal 12. Really, the 12 that goes in place of the y if you're solving algebraically, but if you're doing a graphing calculator, you need both of these equations. So let me do that. So I'm going to go to y equal, and here I'm going to just adjust my mode real quick and get rid of oh, that would be under, sorry, format. I apologize. I was trying to turn off my grid lines. Okay. Just turning off my grid lines so I don't have 1,000 grid lines. Okay. So now let me go to my y equal, clear whatever I have here. And I'm going to re-enter this. I'm going to enter in 10 cosine, making sure my calculator's in radians. Alpha y equal 2 pi over 15, parenthesis x minus 5.6, close, close, plus 7. And I'm also going to have y equal 12. And I'm going to go to my window. And I'm going to adjust my window to fit the screen like the one I have drawn. So I am going to do my x from 0 to, well, it's 20.6. So let's say the 21 by ones is okay, I guess. And then my y, I need to go down to -3. So let's say -5. Let's just go slightly below that. I need to get up to 17. So let's just say 20 by ones is okay. And now I can hit graph. And here's my graph. Now it's going to draw in the line y = 12. And I want to know the first time that it's going to be at the height of 12. And that's going to be right here. So to figure that out, I'm going to use this calc here. So I'm going to do blue second calc. I'm going to go to intersect number 5. And I'm going to arrow up to skip to, arrow up or down skips you from one graph to the other. It's easier to travel on the line than the curve. And I want to go to their first point of intersection, which is right here. Okay. I don't need to be perfectly on it. I can hit enter. Okay. And now second curve, hit enter. Yes, hit enter. And it's at 3.1. That is when it was at a height of 12. So this answer is 3.1 seconds. Again, Desmos is a little easier for this. If I'm doing it on Desmos, okay, I will enter in 10 cosine 2 pi over 15 minus x minus 5.6. And then it was +7. And then my other equation was y = 12. And again, I can come adjust my wrench here if I want. This is okay. So here is my y-axis. This is the first time that it hits that at 3.1. And then again, that's 8.1 and so forth. I can find every time you keep going around and around to that height, but this is the one I want, 3.1. Okay, so that is our answer. Okay, so on example 3, we have a maximum height of 14 meters. Okay, so I'm going to draw in 14. That's going to be my max of 14. And that occurs at 3 a.m. And then the minimum of 6 occurs at 9:15. So 6 minimum. They don't tell me what the middle is, but if I take these values, if I take 14, which is my high, and add it to my low, average them, okay, I get 20 divided by 2, which is 10. So that means my vertical shift is going to be here at 10. And you see that the distance from here to here is 4. So that's my A. And it's also 4 from here to here. And then my K is going to be 10. Okay, so I know that so far. I also know at 3 a.m. So at 3, 14, I'm just going to write the point here, 3, 14. That's my I. They don't tell me what the period is. I do know that the minimum of 6 is at 9:15 a.m. So again, this is time after midnight is what this is. So for this, I'm going to go, so it says let y be the depth of the water and t be the number of hours after midnight. So if it's at 9:15, that's going to be 9.25 hours. Okay, so I'm going to go to 9.25, and that's going to be a low. And again, it's hard to tell from my graph, so I'm going to write 9.25, 6. That's where that is. And I don't know what my period is, but I do know this. I do know that if I'm going from here to here, that would be half of my period. And so from 3 to 9.2 is 6.25. So that means I'm going to go another 6.25. So I'm going to take 9.25 plus 6.25, which is going to be 15.5, and that's where I'm going to end now. Okay, so I'm going to go to 15.5, and that's going to be my high. So this is going to be 15.5 comma 14. And again, what's happening is I'm going another 6.25 to here. And that's putting me at 15.5. So now I have my high at the start and my high at the end. I'm going to do cosine. And if I want to figure out where the zeros are, okay, and when I say zeros, I mean vertical shift, I am going to take my 3 and my 9.25, and I'm going to average those. So I am going to take 3 plus 9.25 divided by 2. And so I am going to take 3 plus 9.25 divided by 2, and I get 6.125. Let's move this slightly. 6.125. And then I am going to take 9.25 plus 15.5 divided by 2 to find the other side. So let me change this to a 15.5, and I end up with 12.375, 12.375. And so those are going to be the values that I have for my middle ones. So I'm going to go to 6.125. So I'm just going to approximate this. 6.125 comma 10. And let's see, 12.375. So 12.375. Again, I'm just approximating it, but I'll put the value. So it's going to be 12.375 comma 10. And then I can draw my graph. Okay, so there's my whole graph. Now I'm going to write this. Well, so they want us as a sine and as a cosine, so they want both of these. I think let's do the cosine one first. That's probably a little easier going from here to here. So this is going to be y equal, my amplitude is 4, it's going to be a positive 4 because I'm starting at the high, cosine. Now to find my b, again, 2 pi over b equals my period. My period is basically 6.25 plus 6.25, which is 12.5, or from 3 to 15.5, which is still 12.5, okay? So I can either go from here to here, which is 12.5, or I take my 6.25 plus my 6.25 to get my answer. So this is going to be 2 pi over 12.5 equals b. And I'm going to put this into my calculator. Okay. So in my calculator, I'm not going to put in the pi. I'm going to do 2 divided by 12.5, which is so this is either going to be 0.16 pi, or if I change that to a fraction, 4 pi over 25. Okay, either one of these is going to be my b. Okay. Okay, so let's say I do the 4 pi over 25. I'm going to start at this value right here, this 3 comma 14. So this is going to be an x minus 3. And then my vertical shift, this is up at 10. So this is going to be a plus 10. So that would be my cosine. Now my sine is going to be basically, most of it's going to be the same. The amplitude is going to be the same, except for maybe the sign is changed. Your B is going to be the same and the K is going to be the same. But the X minus H, that's going to adjust depending on where I'm going to start. I think I'm going to start, and I'm going to circle this in hot pink. I'm going to start here at 6.125. Okay, so I'm going to do y equal, and I'm going to go down first. So that means that this is going to be a negative 4 sine, and my b is going to be the same b that I had over here, 4 pi over 25, or 0.16 pi. Now this x minus 3, I'm not starting at 3, I'm starting at 6.125. So that's what I'm going to put here. X minus 6.125, and then my plus 10, just like the other one. That would be my equation. Either one of these is acceptable. They wanted us to do both of them. Then they wanted us to answer some questions. And I put an X here. I probably should have put a T. T and X, they're the same thing in this problem. Calculate the depth of the water. So I'm going to go negative 4 sine 4 pi over 25, and then I'm going to go 2 minus 6.125 plus 10. I'm going to put that into my calculator. Okay, making sure my calculator's in radians. So negative 4, and it doesn't matter if I do it into the sine or the cosine, doesn't really matter. I probably should have done it. You know what? I'm going to do this. I'm going to do it into the cosine because it's less for me to type in. It's a little easier looking equation. So here, let's do it into 4 cosine 4 pi. It doesn't really matter, but 4 pi over 25, and then 2 minus 3 plus 10. That's probably a little easier math to work out. Okay, so I'm going to do for cosine of 4 pi over 25 times 2 minus 3, close, close, plus 10, and I get 13 point, let's say about 13.5 feet as our answer. Then at 2100 hours, that means 21 hours is what I'm going to be putting in because this is in military time. So I'm just going to get this here. Now, if I copied this and I want to put a 1 here, I'm going to hit the second and insert for the delete for the word insert when I have my cursor where I want to type in front of, and then it doesn't type over. And I got 6.28. So this is about let's say about 6.3 feet is that answer. Write down the maximum depth of the water in the harbor. So the maximum depth of the water in the harbor. So the maximum depth, if we're looking at our thing, is 14. The minimum depth is 6. So the maximum depth is 14. Okay, so they want 14 feet here. And they say calculate the value of T when the water is first at that maximum depth during the day. So I am basically going to want to know, when does this equal 14? And I'm going to use the cosine graph. I think that'll be easy one to type in again. Okay, so if I'm doing this on the graphing calculator, I'm going to go to y equal. This is now going to be 4 cosine, and this is going to be a 4 pi over 25. This is going to be an x minus 3. And then it is a plus 10. And then we want to know when it is 14. Okay. And I'm going to go to the window on the calculator. And if I'm looking at this, we're going 0 to 24 hours, okay, in a day. We're going from 0 to, let's say, 15. I'm going to scale it the way it is in the picture. So 0 to 15. And then I'm going to hit graph. And so there's my graph. And then there is our 14. So it looks like the first time is at 3, but let's just make sure that that's at 3. So again, you can do second and calc, and we can go to intersect. I'm going to arrow up or down to get to the line and move on the line. And then hit enter, enter, enter. It's thinking. And so it's giving me 2.99997. That is 3. Okay, and we can see that from our graph that it was 3 right here. Okay. So that ends up being at 3 a.m. That's the first time. Now, this one, it says the harbor gates are closed when the depth of the water is less than 7 meters. Okay, so under 7 meters. An alarm rings when the gates are opened and closed. So when it hits 7 meters, the alarm's gonna go on or off. And it says how many times does the alarm sound during the day? Okay, so if I go back to my graphing calculator and I go back to y equal and I change this to 7, okay, and I hit graph, and I want to see how many times my y equals 7 line crosses this. So 1, 2, 3, 4 in 24 hours. 1, 2, 3, 4. So this is going to be 4 times. Again, every time it's at 7, it's going to have the alarm go off. Okay. It says find the value of t the first time that the sound goes off. So again, I can do second and calculate button. Go to my intersection. I can just press number 5. I'm going to drop down to the line, and I want the first one, which is around here. And I'm going to hit enter, enter, enter. And then it says 7.8 hours. So at 7.8 hours is when the first time, so that this is. And it says use the graph to find the length of time during the day when the harbor gates are closed. Okay. So for this, use the graph to find the, okay, so let's, I'm going to do this on Desmos. I can do it here and kind of figure out, but I'm going to do it on Desmos. So let me get my Desmos up. Okay. And I am going to be putting in our equation. So y is equal to 4 cosine of, and here, let me, oops. Let me get this back up. Let me get it back up. Hold on. So I'm just getting my equation. And again, I'm going to use the cosine equation. It's going to probably be the easiest. So 4 pi divided by 25. And I'm going to put parentheses around this. And then I'm going to have times, and actually, hold on, let me restart this. Y equal 4 cosine of 4 pi divided by 25 times x minus 3, close, plus 10. And then it was y equals 7. Okay. And we want to know, let me just double check this. Use the graph to find the length of time during the day when the harbor gates are closed. And they are closed when the depth of the water is less than 7. Okay. Okay, so this here, when we want it when it's less than 7. Okay, so as I'm coming here, this is more, so it's open, 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 closed. Right here to here, it's closed. And then it's open, 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 closed from here to here. And then open, open, open. And then when I get over here, that's beyond 24 hours. Okay, so let me get something to write with. And so I am going to be, it's going to be closed from here to here. Let me make that a little thicker. Okay, so from here to here. So I'm going to be basically subtracting these from each other. And then again from here to here. Now, if I subtract those should be the same. So let me get my calculator here for a sec. Okay. So I'm going to take 10.688 minus 7.812, and I get 2.876. I should be getting the same when I do this other two. Let me just double check. 20.312. So I get the same thing. So I'm going to basically double this, and I get 5.752 hours. Okay. So let me get back to my other one. Give me one sec to get out of the, okay. Okay, so let me now clear. Okay. So it ended up being 2.876 times 2, which is 5.752 hours. And that's the end of our notes for today. if you weren't here in class today, we actually didn't get through all of number 3 in period 3, and period 2, we didn't even start on number 3. So we'll be finishing from where we were.